router. So the problem is that so whatever changes that we need to do at the controller have to be burned into the router firmware. So that leads to a lot of problems. Sometimes the manufacturer might say they can't do it, or it's a very long time because there's development cycle. So it takes a longer time. So software-defined networking, what they try to achieve is that the control plane and the data plane has to be different layers. So we can do all whatever the changes that we need to do at the control layer. So you might why I selected that methodology to extract parameters. So as you can see that most of the trust values happens at the application layer. It can be the Facebook, it can be on other software layers. So by using software-defined networking principle, so you can isolate some of the trust parameters and retrieve those parameters through a separate control plane. And also, later on you see there are the advantages. So one of the values of using software-defined network is it's locally centralized intelligence. So the problems with the mobile ad-hoc network is that can be mobile users. So mostly moving from one network to the other. So that's the biggest challenge. When you have a centralized software layer, you can which you can coordinate into one location. So even the mobile node moves from one place to the other. Make it a much more simpler view. Say there's a mobile user coming from one building to the other building. So maybe the node can be new, the device can be new, but information about the user exists in the central internet network. So value of that would be even a device can be new, the information that controls the control plane can be quickly and flexibly can be taken into the real network. And also, software-defined networking means the network layer can be the hardware, but the control layer is software. So we can do a lot of programming. As you know, programming can lead to new creation. So by programmatically, we can control all the network communication. Helps us a lot. And also, it provides the great abstraction to provide value-added services. So now, why you might think once again, like, is the best solution, because if it was security, in a normal network, we might need to implement this sort of, like, as you can see in the slide, there can be a lot of technology which are being inbuilt into the network layer. So now the freedom that we get is some of these controls can be taken into the control plane. So if I show this slide, so fast modeling the software-defined network would be better. So one is it's moving hardware nodes, but share can be static. So that's useful. And also, control plane can access overlay data like Facebook, Twitter, and the other data, which can be very useful to develop and model. And also, this time I have to explain that most trust parameters are human based. So there is a human interaction element to this as well. So from user to other user, there can be a lot of human parameters, so which also can be captured for calculation purposes. And same time, trust is subjective, and so node can come from anywhere. So which I explained earlier. This sort of a networking diagram or overall architectural diagram of software-defined network. So as if you can see this, that there is this open flow firmware is kind of a control layer that goes on top of the hardware. So whatever the changes that we can do done at that control layer. So now if I taking you to the second module, so this is some work that I've done on this particular module to create a trust prediction framework. So that I have used Markov process. So why I use the Markov process is to explain that I first explain the architectural view of the trust model. As I explained earlier, So what I'm using is hierarchical routing. So ideally, what's happening here is that I'm going to create some clusters in network. So depending on different characteristics, I'm going to prepare some clusters in the mobile network. Rather one node sitting and transmitting, there can be different clusters in the network who will be transferring information. So if one node is in a cluster, so what they need to do, first communicate with the cluster head. There will be a cluster head, and the cluster head will do the communication for the particular node. At the same time, there can be one particular node which is outside a cluster. So mere untrustworthy node. So now with the clustering concept, when I consider the small world theory, what it was two different concepts of chains. So now what I'm doing here is connecting clusters with something called long trust chain. So intercluster chain. So basically the elements of this cluster chain would be cluster head, and cluster will be connected in the chain, and we can find out a kind of long trust chain where we want to send data from one cluster to the other. Similarly, inside the cluster, there can be shorter trust chains. So the idea is to find out long chains and short trust chains to communicate or to do routing. So as you can see, so this is some information about what's inside a cluster. So it's true that there's a cluster head to a cluster, and there's a cluster member, and also there can be a cluster gateway, which is actually connecting different clusters. So I'm taking you to why I'm using the hidden or the Markov theory. When you look at a trust chain, so important to understand is that trust of a node completely depend on other two nodes surrounding that particular node in chain. So if A and B are two nodes connected, the trust on A completely depends on who is. So this is the same principle used in Markov theory. So I'm using Markov theory for this prediction framework. And here I'm having some observable information, and also unobservable information. So what's very difficult or very unobservable at this particular situation is the given node is in the cluster or outside the cluster. So depending on that, the trust level might change. So keep that in mind. So we have developed a prediction mechanism using hidden model. So this is a particular calculation or the equation that I'm predicting or using for developing the trust. So this equation might change in the long run the output of the first module. So I think the chain position is property of that of included cluster of the node. Particular HMM model, the functions along the chain as belonging to either one of two trust levels, whether inside or outside. And look at the node, or especially initial node present outside. So there can be several reasons that we need to set as outside the cluster. We can't take it to the inside cluster. So these are the reasons. One particular reason would be a node be introduced for the first time. So that the first time node will be always at the outside the cluster. Second is node moves from cluster because there is high mobility in the MANET network. Given a point, a node can be quickly moved away from the cluster. So that and also from the cluster. So if we like that a node is malicious, we are having a situation where the nodes are untrustworthy and they are outside. But we can't rule out the situation where they have some level of trust, but we can say they are majorly untrustworthy. So that's the expression. So this is the level of implementation of using R. So here I've used parameters which are dummy values. So because I've not clearly identified the probabilities which really would really define these trust values. But as you can see, I have defined two states. One is called inside, one is called outside. Because depending on inside and outside, the trust value would change. So and then I have created some different probability values. Depending on I have few different trust values. So this is called the transition matrix. Transition matrix, I can create a trust chain. So that's what I'm targeting at. So given different trust probability values, we're having different level of trust. Now, as an example, so if you are in level A, you are highly trustworthy, and B, you have somewhat trustworthy. C, trustworthy. So it's a sort of a very simple breakdown of trust, which we can use to take decisions on routing later on. And these all values are dummy values, just to fix in and see whether trust chain can be calculated. So I'm pointing out these trust values might change depending on the outcome of module 1. So this is the emission matrix. The emission matrix is needed to change different trust levels. So when you are inside a cluster, trust levels might be different, or the trust levels for probabilities for trust levels might be different. When you're outside, probability values for trust levels would be different. So this particular matrix that you can see in pink color will be created using these rulings, and this is the final outcome. Kind of a equation to create the trust prediction value. So this one is available equation, or sorry. So this will be changed a little bit later on. But we can get a chunk of trust like this. So as you can see, so this is related to a particular node. So what you are seeing here is that levels of trust generated for a given set of nodes. So depending on this sort of trust chain, I can later on make decisions. So routing path to be, now as an example, the first state, it explains at trust, it's inside, state is inside, and trust level is the. So obviously that particular router or that particular node can be trust move. Second takes the one of the other nodes is outside, and also the trust level is D. So which is a clear indication that it cannot be trusted at the same level. So this sort of prediction chain will be created at each node. So when protocol is running, so this will be created at each node, which are information for them to take decisions later on. And in HMM, it's a famous algorithm, video algorithm used to do searching. So after the trust chains are created, given a situation where we need to take decisions moving or routing information, Viterbi can be used to generate or search for through the trust. So we implemented, like I explained earlier, through the MANET protocol. So then I'll take you to module 3. So in 3, what I'm going to do is using NS3, I will implement that this is set present framework. So really I'll get parameters from the software-defined network and network layer, and then push it to the prediction framework. And then using Viterbi or similar algorithm, I'll take decisions on routing. So this will be first implemented using Batman, and similarly two backup routing protocols using AOD and SPV for the benchmarking class, and finally it will be implemented on Batman. And in the real implementation using and it will be implemented as a kernel module. So these are all features, especially in the third. And this will be the simulation framework that I'm going to use. So very much important to keep a framework and also a kind of assumption-based framework. So this is what I'm going to use for the testing purposes. All the for the presentation. Questions? Hello?
Yeah. Questions? On the okay, then it wasn't really covered why this trust relationship in our particular circumstances. So this is to fit in with the indoor navigation and the between using a given environment. We really need this trust system in a scenario like that.
Now, situation in this in application in indoor navigation system, will be created by the users. Even it's not crowdsourced, but information will be created or the will be developed by the information that is generated from mobile. So what if some of these mobile nodes can be malicious? Or what if these mobile nodes can be root? So there we need initially, like the generation of data, we need the nodes to be trusted. Second point, after we create the map, say we communicate with the node to get information. So because we have to base our information on the ad hoc network, so we can't directly communicate to the server. So we have to jump from to the other node and get information. So a rogue node, malicious node can feed us information which are incorrect. So it should be very much clear that if we can't trust these nodes, we can't communicate. So the easiest solution is to always do authentication using a normal security protocol. But it will be very challenging to implement something similar using security protocols in such a situation. So that's where we need to come up with another parameter called trust. So if already developed trust implementation, we are in no need of doing authentication. And that's the logic here. It's similar to this, like when you find one of your friends to a house, you don't need to show ID card or check securities. But if there's someone new house, you always ask for credentials. But at the same time, there's somebody new coming to us, but with recommendation of someone, you that person. Recommendation is already given. We already trust the person. So when you're inside, you might have seen the photo before, or you might have some information about that person, some recommendations. Already trust the person. So that is the logic why this trust is useful and valuable for the implementation.
So small world phenomena is saying that everyone's known to a certain distance, within a certain distance.
That's right. In applying small world theory here, you really now the worry is that will you be able to find this information? Is it that? So if you think, okay, read from the internet, but it's a huge place. So how do you find the relevant information? But in all theory, you don't need to worry too much about it. By running through 6 jumps, talking to 5 intermediate people or 5 intermediate nodes, you can all retrieve that information. So that's what small world theory says.
And I'm not because I lost audio for a couple of minutes there. What printers, again, in the scenario we're talking about, what printers will you use to determine this trust? So
first of all, will be like parameters coming from 2 different layers, the network and the data link layers. So there I have to use the more straightforward parameters like now data communication, of data communication. So more data communication that is done, more probably a person would be or a node would be, less the number of delay and lesser or more the number of or more amount of power for a given node, because if having these are mobile nodes that we're talking about, having lesser power levels, So obviously we can't trust them because they might move out the network very soon and have more bandwidth. So these are the normal trust parameters in the network layer. But so you can ask this question straightforward. You can ask this question. So how do you having a malicious node cannot be in the network for a very long time and tends to that you trust that person. So yes, that can happen. So because trust is coming not on a machine level, so it moves a little ahead from the machine level and to other layers like overlay networks. So we need to look at the human factors. So a lot of research being done at the human over. So we can easily retain those other trust level parameters. As an example, a number of now if you get a phone, you can have address book, and in address book you can have the address of some mobile phone and a user, and in other device the same address book remains. So that's an information that to say that this is some trustworthy device, and ultimately so we can take it as a parameter. Similarly, if the same device is using social networks, so they already created trusted. Say as an example, they may be using OpenID, and there are some authentication at the Internet of Communication. So it leads to more overlay already created trust through security mechanisms. We don't need to do that process and waste our energy in the node. We can quickly get that parameter from the network. At the moment, it seems like software-defined networking provides the best architectural support for that, and we use heavy industry. So that's why sort of using the second step to get those parameters.
Getting an extensible for the trust, or something that can be used in such as crowdsourcing. Would you agree?
So you asked whether it can be used for applications as well?
Extensible set of parameters for the trust values.
Yeah.
Sorry from over there, I think. So you'd be used in other areas?
Yeah, because now one of the other concepts would be like even for from my research, like this information would be so that information can be taken out from other places and can be reused. One of the areas that I can think of is even for map building. So information can be process information can be found through this software-defined networking, because the layers would consist of that information, and it will be much flexible. It still works like a used working protocol. So it will be very efficient to review and to get that information. Originated from the same location, but other locations.
Okay. Anyone else? Recording.
Yes.
Yeah. About time taken trust relationship.
Actually, not at this particular point, because I have to do some more work. I kind of looking at the amount of time that takes to create all this. But one of the huge advantages would that most of that information will be pre-processed. Because so when new node is being added, so some of this information is already pre-processed. So like normal protocol, you don't have to do work on that. If you're using some all the information is already been processed for you. So the information is already available, which you can quickly which you can access. Plus, when the main problem I was faced was to how to minimize the time on authentication. So if we works out, authentication time would be 0. Because you do any authentication because already you are in the trustworthy network. But my plan is to use some set of cryptography later on. I fuse the two methods and see what is the most optimum method rather than just working on this trust value. So it will be on trust, but cryptography also we use as planned.
Okay.
Thank you for that. More questions?
Thank you.
Okay, so you can stop the recording, I think.
Okay, thanks.